I'm wondering if you know how to pace. When you were told that you have ME or CFS or long COVID and they told you to pace, did you have the slightest idea what they were talking about? And even after you've looked at various ideas of how to do it, do you know why it works or how to do it? Well, this is an in-depth scientific slideshow that is going to require some level of commitment to learn, but it's worth it. I feel like anybody that's diagnosed with ME/CFS or long COVID ends up with a degree in biochemistry just so that we can survive. And it's very difficult to sort through what is true and what isn't and how to do it. And so I'm here to clear up some of those questions. My name is Cindi Leacock, and I have a master's degree from the School of Public Health at the University of Michigan. And I have created the yellow light method as a way to heal from ME, CFS, and long COVID, which is the type that has ME/CFS is created. So we want to prevent post-exertional malaise and produce more energy or more ATP, and by pacing, that's the goal of it. So our recovery occurs when the body can repeatedly produce energy without triggering the protective stress response that causes post-exertional malaise, PEM. Over time, stable energy production, autonomic system calming, improved circulation, mitochondrial signaling, and reduced inflammatory stress may allow for greater functional ATP availability and tolerance. So how do we reduce having post-exertional malaise over and over again? Every crash appears to consume large amounts of recovery resources. It creates oxidative stress, inflammatory signaling, autonomic overactivation, and impaired oxygen utilization. So fewer crashes may allow more cellular repair systems to catch up and you recover faster. So learning how to stop at your yellow light symptoms helps you to prevent having PEM. And the longer you can go without PEM, the faster you're going to get well. Second of all, we want to give mitochondria a low demand repetition of daily activities. Mitochondrial remodeling adaptation means that the mitochondria are dynamic. In many illnesses and in deconditioning states, mitochondrial efficiency drops. So a stable low demand of repetition may allow for improved mitochondrial enzyme function, better oxidative phosphorylation efficiency, mitochondrial biogenesis signaling, improved oxygen extraction and utilization, and this is well established in exercise physiology generally, though not fully mapped in ME/CFS specifically. Third, we want to stabilize your nervous system. This is so key and it's so approachable. We can do this. Autonomic nervous system stabilization requires us to maybe take calming supplements. And I don't know what those are for you. You have to find out with your healthcare practitioner or through ChatGPT or whatever mechanism you have for determining your appropriate supplements. But anything you can do to calm down your nervous system is going to prevent dysautonomia, excessive sympathetic activation, poor blood flow regulation, reduced cerebral perfusion, which means not too much blood going to the brain, impaired oxygen delivery. So when activity remains below the threat threshold, the nervous system gradually stops reacting as if exertion is dangerous, and then it can improve circulation and energy availability. Fourth, we want to stay below capacity. That means you already have built up a certain amount of energy, a certain amount of capacity for what your activities are every day, and then you crash. But you always want to stay right below what you're able to do and very gradually expand it. That avoids the anaerobic trap, and that's research by people like Christopher Snell and Stacy Stevens that showed that many ME/CFS patients hit anaerobic metabolism abnormally early and worsen after exceeding it. Repeatedly staying beneath that threshold may reduce metabolic injury and allow gradual expansion of tolerance. Fifth, tiny increases in activity prevents PEM. Improved conditioning without triggering pathology, PEM. There is a difference between healthy conditioning, which is really gradually, slowly doing an activity and increasing that over time, over weeks. That's healthy conditioning as opposed to provoking PEM. Tiny, stable increments that may permit genuine conditioning effects, in other words, developing your ability to do more exercise effects while avoiding the biochemical cascade of PEM. And that is the key to recovering from this illness, doing tiny, stable increments of exercise. Neuroimmune downregulation also prevents PEM. Some researchers believe that persistent cell danger response signaling or neuroimmune sensitization keeps the body locked in energy conservation protection mode. So what we want to do is predictable, non-threatening activity that may gradually reduce this overprotection. What science has not proven yet is that mitochondria literally require exactly the same minute count every day of what you do for activities, or that ATP capacity can be measured directly in day-to-day clinically, that all ME/CFS is primarily mitochondrial. For example, recent research is pointing to a change in synaptic activity as well, and that one protocol works universally. So in other words, you need an individual plan that works for you. Having ChatGPT create a personalized protocol daily changes everything for you and provides maximum safety. So these are your key yellow light physiological signs. When I'm saying the yellow light means I've just reached my capacity. My body has a desire to close my eyes. I'm short of breath. I feel like I've just got to do one more thing. Your heart rate's over 100. You're having a desire to lie down. You feel tightness in your jaw, and you have other yellow light symptoms that are unique to you that you need to learn. So pay attention to what those are, and the faster you stop activity, stop at the yellow light, the physiological signs, and prevent a crash. Lie down for 30 to 90 minutes until the nervous system stabilizes and reduce your stimulation. Now, these are all the scientific studies that support the yellow light method. Not all of them, these are some of them. There's a 2-day CPET study, objective evidence of impaired recovery, the most important physiological evidence in ME/CFS. The key finding was ME/CFS patients often cannot reproduce their energy output on the second day of testing, unlike healthy or merely deconditioned control subjects. This strongly suggests impaired energy recovery, abnormal oxygen utilization, early anaerobic transition, and post-exertional metabolic dysfunction. The Workwell Foundation did some anaerobic threshold research associated with exercise physiologist Stacy Stevens and Christopher Snell, And their key finding was that ME/CFS patients hit anaerobic metabolism at abnormally low exertion levels. Crossing this threshold appears linked to PEM. Why that matters? This directly supports staying below the physiological stress limits, the tiny increases instead of aggressive exercise, aggressive conditioning, symptom contingent progression. This is one of the scientific foundations for pacing. David Systrom's ICEPT research on impaired oxygen extraction showed that many MECFS patients showed impaired oxygen extraction, autonomic dysregulation, abnormal blood flow during exertion, meaning that oxygen may reach tissues poorly or mitochondria may not use oxygen effectively. Why does this matter? It supports the concept that patients are not merely out of shape. Exertion physiology is biologically altered. Gradual stabilization may improve delivery and utilization systems. Then there's the mitochondrial cellular energy failure research, and the key findings there were multiple studies that suggested mitochondrial dysfunction, altered oxidative phosphorylation. Yeah, this is my downfall. Phosphorylation, hypometabolic state, abnormal lactate handling, oxidative stress, impaired ATP production pathways. Why does that matter? This supports your core intuition. Recovery may involve restoring stable cellular energy production capacity, but scientifically, it's safer to say improved functional energy metabolism rather than direct ATP building. So when I say in the slides, this is the way you create ATP, really what you're doing is improving your energy metabolism. Autonomic nervous system dysfunction research has shown that ME/CFS patients frequently show sympathetic overactivation, reduced vagal tone, orthostatic intolerance, abnormal heart responses, impaired circulation regulation. And why does that matter? This strongly supports the importance of neurologically stabilizing yourself, because recovery may depend not only on muscles or mitochondria, but on autonomic nervous system quieting, reduced threat signaling, and stable neurovascular regulation. The Frontier Reviews discusses altered heart rate regulation, autonomic abnormalities, and reduced vagal modulation. So that's the vagus nerve that needs to be calmed. So if you'd like to take a deeper dive into the yellow light method, learn your physiology, understand how to pace so that you're doing the proper amount of activity every day, I'm going to refer you to my other slides, specifically Part 2, Learn the Yellow Light Method. And I really wish you all the best, and I hope that for those of you who are interested in the science, that this has been helpful, and that you can go back to the various slides and look up the papers that these refer to.